All right, welcome to the next version of Grumpy Science with Mark Tommerdahl and Bob Dennis.
And we have stuff to be grumpy about today.
Oh, yeah.
Like they quit selling my favorite beer at the grocery store. They're re-merchandising.
Gluten-free.
So
it's hard to find.
I found a substitute, so maybe I can still talk, but I just get to be the ugly face on this episode. I'm just reading a bunch. We're trying to catch up on some question answers, and these questions are for Bob. And so I'm just going to read them verbatim.
Well, first of all, let's give credit, right? So
we'll give
these
credit.
are from Richard P., who sent us 2 nice emails, Steve Q., David S., and Jedediah Z. Now, full disclosure, Jedediah Z is my alter ego. No, I'm not. Yes, I am. I'm sorry. He's the person that I channel when I'm trying to remember the many other questions that I got that are similar. So I actually add in to some of these questions that people send me other people's questions, and I've gotten thousands of them really, so that it can kind of fill out the question. I can actually answer more than just one person, maybe hundreds, who are asking the same sorts of things. So Jedediah is my alter ego. Anyway, carry on.
I thought he was your cousin.
No. Okay, Jedediah, calm down or I'm going to get an exorcism, all right? We're going to take care of you once and for all. Mark, please.
I'm sad to hear that you, Bob, need to regularly use your device for your injury. So I was curious if you have already considered a full chiropractic assessment.
Indeed, I have. And I've been getting chiropractic care. I had been getting chiropractic care since I was in college many years ago. I guess that would have been like the late 1980s. Because I've always had back problems, and it's actually really only been the last 4 or 5 years where I haven't needed chiropractic care for my back. But thanks for asking. I think chiropractic can be very helpful, and it certainly helped me. But I think by reducing inflammation, using this technology, it's helped me to the point where I don't need strong meds. I just take aspirin, but I do have to use the device all the time.
I think you said in an interview that Micro-Pulse ICES uses a train of pulses like they happen in the development of a fetus.
That is absolutely correct. I'm glad you heard that in that interview. I'm getting a phone call now, so sorry about that. See, during lectures, I'm supposed to keep these things turned off. Oh, that's just an insurance scammer, I'm sure. Anyway, yes, we don't do retakes and we don't edit videos. So stupid stuff happens, right? Anyway, that is precisely correct. I did model the pulses on a micropulse after the pulses that we see during development of the musculoskeletal system. The idea being that during development, you have to have neuromotor activity, muscle contractions, because if you don't, the skeletal system doesn't develop properly in utero. And so it seemed to me at the time, and this is all from research I had done 25 or 30 years ago, that those kinds of stimuli would be related to more sort of basic, fundamental, primal signals that tell us whole organisms to move to a state of growth and development, as opposed to a whole state of decay and apoptosis, right? So I do that. It's one of my working hypotheses that those kinds of neuromotor signals are very important, and it's hard to test. So part of that is just an educated guess.
Alrighty, next question. Can you tell me about the output driver electronics, H-bridge configuration, etc.? I understand that
DI/dt.
No, I don't have my glasses
on. That's how quickly you change the
DI/dt.
current in a coil, right? So you're putting out a pulse. How do you do that? You're changing the current going through a coil.
Yeah, and if I thought about my electronics,
because Mark is an engineer, he knows about this stuff. I just,
I even recognize what an H-bridge is. Used
Yeah.
to know. Are you just calculating
does.
the energy in a capacitor and discharging it, or do you have a powerful enough power supply to sustain a plateau of a few milliseconds? And my intent is to build a pulse generator, not to compete with your product, but just to experiment. Biomed was my first love and still appeals to me. Please tell me about ICES, coil, wire, and inductance so I can build one using
Arduino
or similar, using PC or wireless to control pulses in real time.
So basically, the guy's asking me, how do you build it, right? Because he's an enthusiast. which is cool. I'm all about DIY. In fact, people sort of using parts of my different inventions on different DIY sites. Sometimes I'll chime in and say, well, it works better if you do it this way, right? So for all of the profiteering pirates out there, I have patents and I will come after you, so don't copy it. For all the good people out there who want to actually build something and try to do something good for humanity, I'm all for it, right? So can I tell you about the output driver electronics H-bridge configuration, etc.? Yeah, absolutely. In fact, I published that in 1996 or 1998. I'll try to get a reference and put it in as a link down there in the comments for this video. He understands about the importance of how quickly you turn the coils on and off, and do I have a power supply that's powerful enough to maintain those high levels of current? No. In fact, to make it ultra portable, it kind of runs on a camcorder battery or a 9-volt battery, so I have to use capacitive discharge to get these. They're actually relatively powerful pulses. That's why you can hear it clicking, because the pulse itself is pretty powerful. But what's most important is he asked if it's enough energy to maintain a sort of plateau, and you actually don't need to maintain a plateau. In these trapezoidal pulses, what really matters physiologically is how quick the pulse turns on and how quick the pulse turns off. And nothing really seems to happen biologically when you hold the magnet steady. So I just went ahead and got rid of that. Okay, and that's really the kind of the key to how purely inductive based PEMF works. So you don't need to have a sustained source of energy. You just need okay, we're getting electronics geeky here, but I mean, whatever, right? You can watch other things on YouTube if you don't like it, but it's kind of an LCR, an inductor, capacitor, resistor tuning kind of issue. But the thing that makes it electronically intractable is you've got to tune it to the biology, which is unknown. So you got to take a guess, and that's what I've been working on for like 20 years.
Yeah, sort of on a practical side about building stuff. I remember I used to build the popular electronic stuff when I was a kid, and it seemed like it cost just as much to build it as it did to buy something.
Well, that's a really interesting topic that segues into our next question, and I can tell you, because I've known Mark a long time, truth be told, I don't really drink a lot of beer unless I'm talking to Mark, and then I kind of feel like I need to drink more beer. Normally I'd have 2 or 3 a year, but with Mark around, it's a little more than that. Anyway, but Mark is a long history as a neurophysiologist designing and building his own instrumentation. And I've been doing the same thing for about 30 years. And we both think it's really important. In fact, we're writing a paper on it right now, right, for submission to a really major journal. And we're going to be really grumpy about it. So guess what? You're gonna hear about it in subsequent episodes. So we do have a relevant question. Maybe Mark could go ahead and lay it on me.
All right. Is it important to have a bipolar versus a monopolar pulse? Since ICES works by induction, and each pulse induces 2 pulses in the tissues, one at the leading edge of the pulse, the other at the trailing edge of the pulse. So each magnetic pulse already results in a positive and negative pulse deep in the tissue. If you do need bipolar, have you tried a simpler circuit with double coils?
So this is a combination between one of Richard P's emails and Jedediah Z, who's my alter ego. No, yes you are. Quiet. You don't have to laugh because it's not that funny. It's just me being weird.
I was trying to make people not feel silly for laughing. So.
I think it's funny, so you can go ahead and laugh all you want. I get that question a lot because it's a good technical question. So here's the thing. Bipolar means it goes up electronically, magnetically, and then it goes down negative, right? So positive polarity, negative polarity. And this insight that Richard had is that when I put in a trapezoidal pulse, the first part of the induction happens with the leading, and then the second part of the induction happens with the trailing edge of each pulse. So I get, say, a positive pulse here and then a negative pulse there. So for one magnetic pulse, I'm actually getting 2 pulses of current, one positive and one negative, in the deep tissues. And that is absolutely correct. Is it essential to do that? Well, I've actually published a few papers on this with different kinds of tissue stimulators, and this kind of gets down into the weeds of electronics, but those are actually never perfectly symmetric because of the way transistors work and all that kind of like magical stuff, right? So I actually just make them bipolar with an H-bridge, to answer your other question, because it actually, using paired transistors, because over time it actually cancels out the net ion flux so that ions don't, over time, really have to move very far. And so I'm not actually causing a charge movement, a net charge movement over time in the tissue. It's just forcing the charges to jiggle. And in the experiments that I've done in the past, over the last 25 years or so, that actually does seem to be tolerated better by tissue. So largely, it's not so much a matter of effectiveness. I'm just trying to maximize tissue tolerance, and I'm trying not to force ions to go different places. I'm just trying to move them around, but more or less leave them where they are. So it's an important question, and it does matter. And then he asks, if you do need bipolar, have you tried a simpler circuit with double coils? And he sent a really nice schematic. And the answer is that's identical to the very first circuit that I made in like 1995, and it works fine. It's just, you know, I've kind of developed it past then.
And
so
the last comment, I do have a beer holder on my tractor, and it makes outside work much more enjoyable.
Not a question.
Not a question, but a comment.
Just a comment. And yeah, we're cool.
This time of year, that's sort of what you do from, say, 5 or 6 till 8 or 9 every day, is sit on your tractor and get your work done.
Yeah,
you know,
that's what you want to do. We're not condoning the use of alcohol and equipment, but if you're an adult, you know, you can make that informed decision. So I want to kind of go back to one of the questions where Mark was sort of bringing something up about building your own system with an Arduino or similar, using a PC and wireless and everything. If you're going to be a sort of self-hacker enthusiast and build your own PEMF device, I would like to point out that some people are very sensitive to wireless, and it you know, one of the things I try to do is absolutely minimize the total RF energy. And the other thing Mark and I talk about all the time is that when you build your own instrumentation, you're not saving any money, because it probably, you know, if you wanted to build your own number 2 pencil, you're talking about like $200 to build one. You can buy one for like 22 cents, right?
And yeah, and we've started getting similar questions from people using the brain gauge
Very
because
frequently.
They have software backgrounds and they want to write their own code because they don't realize that it was about a 10-year progression to get to where we are, and
longer than that.
And basically, or some people, well, nobody's actually suggested building their own brain gauge. I guess they wouldn't talk to us if they were going to do that, because.
Well, I've had about 6 different people pirate my technology, and really kind of these vulgar things where they sort of copy and they do a bad job. It's really kind of entertaining. I don't do anything. I just watch because they crash and burn on their own. And because it's really quite difficult to build some of these devices. And, you know, the most recent group that pirated my technology is really funny. I got a copy of it. I'm looking at it. I was going through in my mind, you know, check, you know, hey, I tried that in a design like 15 years ago. It's a really bad design feature. Boy, I'm glad they went ahead and paid for tooling for that, you know. So we do see people constantly trying to rip things off. And what's interesting about that brain gauge, kind of the reason I wanted to bring this up, is that a lot of people think, oh, it's just a vibrator, like a cell phone vibrator in a mouse, in a computer mouse, right? That's all it is. No, it's not. So we're 100% sure, just between, you know, us and both of you viewers, we're 100% sure that somebody's going to take a couple of cell phone vibrators and put them in a mouse somewhere and say, yeah, you know, I'll tell you all about your brain. Yeah, you're fine, whatever. You know. Yeah. Doesn't work that way.
Yeah, go back to one of those old videos about device history.
Yeah,
where we showed the old thing, which actually framed the word grumpy very well on the handle.
It's a real precise scientific instrument that's able to do things of sub-millisecond accuracy, sub-micron position accuracy, and you're really not going to get that with like a motor flinging a weight around from a cell phone vibrator. So while we do encourage people to go ahead and experiment and DIY all you want, and we do not encourage pirates to sell people junk, right? We just want to make the cautionary note that this stuff is not easy to do. You know, maybe smarter people could do it better and faster than we do, but it's there's a lot to it, and we're happy to answer questions about it. It's just building your own, I think you would find, you know, rather expensive and challenging. But anyway, except for maybe the beer holder. He didn't tell us how much that was on his tractor.
Yeah, I don't even know if he built it himself, but you never know.
Maybe he used a commercial one and some hot glue. Anyway, I think that's it.
Winding down. Stay tuned for future episodes. A very, very new next episode or two. We're going to be talking about combined results from brain gauge and Micro-Pulse.
You'll find that very interesting. All right, we'll see you later.